Welcome to Summarize Science, where we break down the most fascinating discoveries in the universe. Today, we are looking at a new study on fast radio bursts, or FRBs. These are incredibly short and powerful radio signals that travel across millions of light years to reach our telescopes. While scientists have known about FRBs for years, a specific mystery called a rotation measure flare is the focus of this paper. To understand this, imagine radio waves passing through a giant cosmic magnet. The way the wave twists tells us about the magnetic environment it passed through. Most of the time, this twisting changes slowly or randomly, but recently, a source called FRB 202202529 showed an abrupt, massive change. This sudden excursion is what researchers call an RM flare. The authors of this paper wanted to know if this was a one-time event or if other repeating radio bursts show similar behavior. By analyzing data from massive radio telescopes like FAST and CHIME, they performed a systematic search for these candidates. They looked at 10 different repeating radio sources to see if any others had these sudden magnetic shifts. Using a statistical method called Gaussian smoothing, they created a baseline to see what the normal behavior for each source looked like. Anything that jumped significantly outside of this baseline was flagged as a potential flare. The study identified two strong candidates with multiple detections in FRB 2012110-2A and FRB 2020112-4A. They also found two more possible events in FRB 20180-916B, though these were detected in only a single observation period. These findings are exciting because they suggest RM flares might be quite common among repeating radio bursts. But what exactly causes a magnetic flare in deep space? One possibility is that the radio burst is passing through a dense filament of magnetized plasma, like a cosmic cloud. Another theory suggests a companion star might be involved, perhaps through a massive eruption or orbital passage. It could even be a signature of a binary system, where two stars are dancing around each other. The data shows that these flares can last anywhere from less than a day to a few weeks. However, the researchers emphasize that these are currently candidates and need more data to be fully confirmed. Identifying these events is difficult because telescopes do not watch the same spot in the sky all the time. If a flare happens when a telescope is pointed elsewhere, we miss the whole thing. This makes high-cadence polarimetric observations essential for future discoveries. To recap, this study shows that the environments around these mysterious radio sources are much more dynamic than previously thought. These flares provide a unique probe into the local conditions of galaxies far beyond our own. Knowing how often these flares occur could help scientists finally solve the mystery of what creates fast radio bursts. It might also reveal new physics about how matter and magnetic fields interact in the extreme conditions of deep space. Thanks for watching Summarize Science, and stay curious about the wonders of the cosmos.